So this question is asking us to work with straight lines, and it's mentioned in the word perpendicular. So as soon as we can see this about straight lines and they're mentioning things like perpendicular, we should be thinking of y equals mx plus c. And again, we should have that picture in our mind that c is the value of the coordinate on the y-axis when x is 0, and m is the gradient of the line. So for every one we go across the scale on the x-axis, then we're going to go up the gradient value. And we should be thinking of things like m is the gradient, and that equals the change in the y-coordinate divided by the change in the x-coordinate. And we should also remember in that the product of two gradients equals -1 when they are perpendicular to each other. And basically what we're saying there is that we had a gradient here, so say this was m1, and then we had another gradient of this line. Perpendicular means that they meet at right angles, and so the gradient of this one would be, for every one we go across, we go down m2. And basically what we're trying to say is that m1 times m2, so in other words the product of the gradient of the two lines must equal -1. So that's how perpendicular gradients work, is that the product of the two gradients of the two lines that meet at right angles to be perpendicular must be -1. So let's have a look at the information now and try and work out how this question is actually going to be solved. So the line meets the line at the point P. Find the equation of the line which is perpendicular to this, which passes through the point P. So this bit of information here, if these two lines meet at the point P, then these two lines must equal each other. So the first thing we've got to do is find out the coordinate of x at that point. So they're telling us that 2x plus 3 equals 4x plus 2. Solve the equations in the normal way. So take away 2x from both sides. So we end up with 3 is equal to 2x plus 2, and then we take away 2 from both sides, so 2x is equal to 1. 3 take away 2 is 1, and we have the 2x. And then this tells me by halving that x is equal to a half. So we know that the point P, so point P has coordinates of a half, and to put it into one of these equations we can find that y is equal to 4x plus 2, so y is equal to 4 times a half plus 2, so that's 4. So we can basically use one of the equations to find out that if we know that x is a half, then we can find the y value, so the coordinate that the point P has is a half 4. It's asking us to find the equation of the line which is perpendicular to this one, which passes through the point P. So in other words, we've got this coordinate at a half 4. We have 2x plus 3 goes through that coordinate, so we've got 2x plus 3 goes through that coordinate. So that's the line y equals 2x plus 3. So we've got this line going through the coordinate of a half 4. And they're basically saying that we've got a perpendicular one to this one. So in other words, we've got a perpendicular line going through there, going through that point, and we want to know its equation. So the first thing we've got to do is, for the perpendicular line, again we should be clear with our workings. So for the perpendicular line, that's what we're going to work out now then. So we know the gradient of the perpendicular line times the gradient of y equals 2x plus 3, because we're dealing with y equals 2x plus 3. So m times 2 must equal -1. So by dividing by 2 we find that m is equal to -1/2. So we know for the perpendicular line its gradient is -1/2. Because it's a straight line, we then know that from y equals mx plus c that y equals -1/2x plus some value. Well, we can use the coordinate here, because we know that's the coordinate of P. We can use this coordinate to find out the C value. So from here we know that 4 is the y value, the half is the x value, so we've got negative a half times a half plus c. 4, well, negative a half times negative half is negative a quarter. Add that across. So we add that across, and then we find that the c value is 4 and a quarter. Put that back into there. That tells us then for the perpendicular line we have y equals negative a half x plus 4 and a quarter. So that will be the equation of the perpendicular line that goes through 2x plus 3 at the point P. So that's how that question could be resolved. Make the two equations equal to each other to find the coordinate of x for P. Use that value for x to find out the y value. Sketch out a little picture to get you an idea of what's going on. Recognise for perpendicular lines that the gradient is times by the two gradients, get an answer of -1. Put the coordinate in, find the value of c. Okay, just a slight additional change to the end of this question. I transferred across 4.5, but we found out the c value was 4 and a quarter. So the final answer for question 14 should be y equals negative a half x plus 4 and a quarter, not 4.5 as I wrote in my original bit. So that's just a quick amendment.